Hi all, this is Mr. Yeager for chemistry. Looking at covalent compound chemical formula writing and naming. Out of all the different types, ionic and acidic and then covalent, this is the one I find to believe is the most simple. Yes, you need to know the prefixes, but man, oh man, if you know the prefixes, it is absolutely telling you the formula without you having to do almost any work. You don't have to do any charges anymore, no balancing of charges or anything like that, no Roman numerals, no hydro versus not hydro. So this is one where if we get these prefixes down, the covalent compounds, I usually see students feeling very good about it. The only thing is that it's only for covalent compounds. We should not be using any prefixes for ionic compounds. So we gotta just make sure that we know it's a covalent compound, and therefore this is how it works. So real quick, before we get to all these things, remember a covalent compound means it's two nonmetals, okay? Two nonmetals, and it's not starting with hydrogen. It can end with hydrogen, but it doesn't start with hydrogen. That would make it an acid. So here we go. Okay, so covalent compounds, we're going to use prefixes because we don't have charges anymore to figure out how to balance it out. So covalent compounds, we don't have a lot of elements to work with. That's another thing. But they can recombine in so many different ways. And so even though we have carbon and fluorine in this compound and carbon and fluorine in another compound, we might have different numbers of them based on how everything is bonding. We don't get that specific into it, but we will make up different formulas that obviously they have the same elements in it. Okay. The other nice thing is we only do binary covalent compounds. There's only going to be two elements. Okay. So here are your prefixes. One way that I always tell somebody to kind of review these is just like walk around, take 10 steps and go mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All right? Even try to count backwards. Deca, nona, octa, hepta, hexa, penta, tetra, tri, di, mono. Okay? Some of them should be pretty clear. I think most people don't have any issues with 3, and then usually 5, 6, 8, and 10. Okay? Because you think of basically how many, that's sided shape. We know hexagons, we know pentagons. Even decade, maybe we don't know decagon, but decade means 10. Octagon, and then obviously tri with triangle. All right? I usually don't have too many issues with mono, meaning 1, and di, meaning 2. The only thing is we don't use bi. Okay? We use di, di. And then the only other ones I ever see people maybe mess up is hepta and nona, because it is odd to get an odd-sided shape like a heptagon or a nonagon. Okay, it's just not that, this doesn't seem ever as organized. All right, but those are your different numbers, and you should be able to learn each of those. Okay, what we basically do is we just add that to the word itself, the element name. If there's no prefix, that means there's only one. So one thing I will point out, I'll go back to the prior page with that. Mono is only ever used on the second element. Okay? We never start with the prefix mono. Okay? If there's only one of those elements, we would just write it like we see on the next example, and then mono if it's on the second element. Okay? So nitrogen trifluoride. So this would just be nitrogen, N, fluoride is F, and tri means 3. So NF3. Next. We can write it out, right? Sulfur chloride. So sulfur and Cl. But it's di. So how many sulfurs? 2. Dichloride. How many? 2. Okay. That's it. That's why I said this should hopefully be a little bit simpler. Okay, nitrogen, dinitrogen, so 2 of them, and then oxide, tetroxide. All right, that's the same as tetraoxide. So tetra means 4. I don't know if you ever played the game Tetris, of the video game Tetris. Think of that. A Tetris is when you got 4 lines and everything goes away, right? So tetra means 4. Diphosphorus, so P2. Trioxide, O3. All right, Tetraiodine, so iodine 4, non-oxide. Okay, so that would be O, and non or nona is 9. One more. Dichlorine heptoxide. So di means 2, oxide means 7. You can see that this presentation, a lot of it is showing obviously that, you know, with oxygen we do take out that A when we put it in. We don't say heptoxide, but I will say that we don't necessarily count it off either if you write hepta. This one should be S3N4, N2O7. All right, naming, well, you just got to know those prefixes, okay? So we just go backwards, okay? We do use the less electronegative element is first in the chemical formula. I mean, that's already going to be written there for you. The first element has a prefix except if there's one, only one. So we don't use mono. It says only if there's more than one atom. I can easily just say don't use mono. And then the second element, we always have a prefix on it, and we change the ending to "ide," just like ionic. So there's some similarities there with it. We do end with "ide." All right. So N2O. I mean, the only thing that people get annoyed with this is the names along. So I have 2 N's, so that would be dinitrogen, and then 1 O. Okay, again, you got to look for the subscript after the element. Please don't mess that up all of a sudden where you put the 2 with the O. The subscript always goes with the element before it. So there's only 1 O, so that would be mono. But when we do with oxygen, we get usually rid of that last vowel, and so this would be monoxide, monooxide or monoxide. PCl3, P, phosphorus. There's only one, so no prefix. And then 3 chlorines. 3 is trichloride. You can do like 2 more because this is pretty much it. You just need to know your prefixes. Sulfur, no prefix, has no number, it's just one of them. 6 fluorides, that's hexafluoride. One more. Well, let's do one with, there we go, let's do this one. C5H10. C5, 5 is pentacarbon. 10 hydrogens. Now again, this is not an acid because hydrogen is second this time. So we would do deca, and hydrogen we change to hydride. So that's a good one I'm glad we did that. Hydrogen becomes hydride. So pentacarbon, decahydride. To go back, this should have been oxygen difluoride. This one's going to be dichlorine octoxide or octaoxide. Tetraphosphorus hexoxide. Carbon monoxide. The end. All right, so that's it for that one. Hopefully we get the idea and go from there, and now you'll have them all mixed up, so that'll be the tough part. Good luck, good luck.